Before we get started, we want to let you know that the Talking Cars team is going to be in New York City for this year's New York Auto Show, and we want to meet up with you, our fans of the podcast. We'll be at the Canuck Sports Bar in Manhattan on Wednesday, April 1st at 5 p.m. Come in for a bite. We'll be talking about what we saw at the show and handing out some groovy Consumer Reports swag. So if you're in the neighborhood, stop by because we'd love to talk cars with you. And now on to the episode.
Welcome back to the Talking Cars podcast. I'm Alex Nizick.
I'm Michael Crossan.
And I'm Aubrey Wishegrad.
And Aubrey, welcome to the podcast. You may have seen him before on one of our end-of-year shows, but you are an automotive engineer here at CR on the testing team. And today we are talking about our EV range test and the results from the most recent kind of season of testing. We do this over the summer, as we'll talk about, but both of you guys contribute and kind of run this test and collect a lot of the data and analyze it and everything. So it's awesome to have you both here. So we're going to go through the results. We have them posted on our website, so you can go find all the nitty-gritty details. But essentially, we ran a bunch of EVs through our test this year. So, Mike, let's start with you. Tell us a little bit about what this test actually is and how we conduct it.
Yeah, so it is a real-world highway range test for these electric vehicles. We conduct it at 70 miles an hour out on highways in Connecticut. And we have test parameters and conditions set up that we try to basically be as fair as we can to every different car. You know, we can't test them all in the same day. So we have a weather range or temperature range, I should say. You know, we don't run in the rain and things like that. And all of our drivers are trained too in both the data collection side, but also just how we operate the vehicle so we can be as even across the board in our testing.
Right.
And we just want to see how far will these cars go on the highway on a single charge at 70 miles an hour.
Right. And I mean, why? Why are we doing this, right? I mean, this is a lot of work, right, to drive what amounts to hours on end.
Yeah, I mean,
right?
Some people spend their summer at the beach. We spend them in electric vehicles on the highway. So the why is, if you own an electric vehicle or you're thinking about electric vehicle, when you're driving to and from work, you know, you're sort of within your little bubble, right? You have maybe your home charging infrastructure. You know the places where you can charge on the road where you go. But if you're thinking about doing a road trip in one, you're away from home. It'd be nice to know how far the car will go, what you can expect. It would be nice to know how the vehicle behaves as it gets low on state of charge, because you don't know necessarily where you're going to be able to charge. You're out on the road, you know, you're hopefully not using your phone, you're using the native nav, you have a co-pilot who's trying to find that charging location. It's just nice to be able to kind of have an understanding of what this car is going to do.
Yeah, you know, that if you have a EV with 300 miles of range, it becomes somewhat of a convenience during the week, right? Or you know, you're commuting, maybe you don't have to charge it every single day.
Correct.
But when you're going on that long trip to an unfamiliar place, that's when you really need to know, we feel, how far your car is going to be able to go.
Yeah, and you might push to a lower SOC on a road trip than you do in your average day-to-day, which may or may not be a good idea. You know, at least if you know, I'm headed home, and it usually takes me 12% to get there.
Right.
You know, I'm very comfortable pushing that car on the way home. As it turns out, I'm actually very comfortable pushing a car now really low anyway, having done all of this.
And spoiler alert, that depends what car you're in.
It sure does.
What brand you're in, especially.
Right. So a little bit more on how we do this, right? Because there are some other, you know, outlets or whatever that are doing tests and, you know, it helps that we buy all the cars, right? Because we can be a little bit more choosy on the day and be a little bit more consistent. But how about getting them down to their low SOC, right? That can be a little bit of a sketchy endeavor at times, right? So how do we go about that?
So we're out on the highway and we are just sort of monitoring. And of course, the car has its SOC, it has its range. Some do, some don't. It depends on the vehicle. But you, as a driver, and especially after doing this many, many times, you get pretty good at sort of sensing how a car is going to do towards the end, but there are, you know, surprises that do come up.
I think Aubrey is going to tell us about one.
And because ultimately, I mean,
a good story.
You know, I've driven these cars, you've driven them, Aubrey's driven them, Mike Quincy's driven them, Joe's driven them. We have a bunch of people that drive them. But from a, you know, we're the people sending other people out to do this test. We don't want people dying on the side of the highway.
The cars dying.
The cars, yeah, well, or the people too, for that matter. But the cars, right? So you know, you want to be able to pull off the highway safely.
Right.
So theoretically, we're leaving a little bit on the table, but the idea is we drive the car to an indicated 0 SOC and 0 range. And they generally happen pretty close, within about a mile or so from each other. You know, sometimes you'll hit one just before the other, kind of a thing. They don't necessarily both tick over at the same time. But that comes into play, right? So it's a stretch of highway that we're very familiar with. I actually mapped all of the exits. You're like, this is an exit you don't want to get off. This is a good exit. There's shade here, you know, to park the car. Because we're doing this in the summer. It could be 85 degrees and sunny. And you've been in a car all day and you're already kind of tired. And a lot of these EVs have the glass roof. So like you've had the sun beating down on you and things like that.
Right. We're trying to control for the fact that, you know, ultimately the car has to sit for a little bit before we bring it back to the track. We're trying to not sit there with the AC on, right?
Correct.
So parking in the shade, get inside, and trying to keep things as consistent as we can.
You know, we do tow the car back again because we don't want the car grinding to a halt on the side of the highway. So we pull off at 0. We have a tow company that is on call. They know we're out there, and all of us as drivers have gotten pretty good at knowing where we're going to end. But they pick us up, bring us back to the track, and then we do finish the test here on the track. So it's a controlled environment. So when the car does grind to a halt, it's a safe way and a controlled way to finish the test.
Yeah, absolutely. So Aubrey, another kind of some of the feedback we hear, and totally we recognize this too, is that while it's natural to compare what we're doing to the EPA in terms of the numbers we get, how is this different than what the EPA is doing? Because it is quite different.
Yeah. So the EPA's range testing requirements are basically laboratory tests. There's set dynamometer cycles that manufacturers run. Their target for reporting is 55% city, 45% highway. And there's several different methods where manufacturers can report that. There's a 5-cycle test method, can be substituted with the 2-cycle test method. But the point is, this is a laboratory test and it's reported by the manufacturers, with the EPA basically reserving the right to confirm or deny.
Self-certification.
Right,
basically.
self-certification. And because of that, manufacturers, some, their EPA range is lower than it actually is. Others, it's higher than it actually is.
Which isn't unexpected, right? Because we're doing real world. That's laboratory. There's 2 different methods, as you pointed out, which are going to yield potentially different results, even if you took the same card through them. You know, maybe counterintuitively, if you're used to a gas car, is EVs are generally less efficient on the highway. So if you take a combined cycle and then all of a sudden you're comparing it to just going 70 nonstop, all else the same, you would expect that car to actually do worse in that situation, right? Worse in terms of less range, less efficient.
Yeah, and I think generally that's true, but there are some cars where they do better.
Absolutely.
Again, it varies, and we'll get into that.
Yeah. So speaking of that, well, before we get into the trends, and you know, this is going to be us going full nerd on EVs and the results, and of course, we can't cover everything, so you're going to be able to find even more of that on our website. But before we get to some of the trends and some of the observations, Mike, if you could tell us, and Aubrey, just some of the test conditions, right? How do we control this? You know, of course, we've mentioned temperature ranges and things like that. Climate use is an obvious one, but we go further than that, and we really try to make sure that the cars are as comparable as we can, right?
Yeah. So you mentioned earlier that we buy and we own all these cars, which is great because we can choose when to do them. And famously, Consumer Reports, when we test cars, we put 2,000 break-in miles before we begin any testing. And we have a similar situation here with these EVs. And of course, we're testing these cars as part of the regular test program too. So we wait till they have at least 2,500 miles of driving on them, and then we cap that at 9,000 miles. We want to have a narrow window because as an EV ages, a couple of things happen. The tires get worn down, and that changes efficiency, but also there's the more charging cycles that have happened on a battery. The batteries can degrade over time. So we have this mileage window where
we want some charge cycles through that.
Correct.
Battery,
we don't want a brand new car, you know, straight off the lot, go do the test. And then our temperature range is 70 to 90 degrees Fahrenheit. So we need to monitor that. And, you know, depending on when you're doing it late in the season, like temperatures do start to kind of drop in the afternoon. And so we've had some close calls on that. But, you know,
and this is one in particular where we get, you know, just getting in front of some of the criticism, right? Ultimately, we want to do this test in one day. And if we're talking about, I don't know, Silverado EV, where we got 450 hours and hours. So we need to give ourselves enough room to actually complete the test.
Yeah, absolutely.
Right? So,
and one thing to point out about that temperature range is that's the temperature at our track. Right. We have a weather station at our track. It's very accurate. And that's where we're measuring the temperature. So it is possible theoretically that 50 miles away when we're on our route, the temperature is a few degrees different. But we don't have an accurate way to measure that. So this is at our track, and
it's more about being consistent.
Correct.
Yep, exactly. Yep.
And wind matters, because you're essentially fighting wind resistance as you're driving. So maximum of 15 miles per hour, measured at the track. We check it when we start, when we end. As long as we were, overall within that range, it is a good test. And then we want a clear, so ideally no cloud or partially cloud. We don't want total cloud cover because sun load matters when it comes to the climate systems. And then no rain, because you're running windshield wipers and things, but it's really the water that the tires are evacuating on the roadway. That's a lot of, we all know water's heavy, so that's a lot of effort that happens. That would greatly reduce.
And you're running wipers at that point and things.
It would have an effect.
Right, absolutely. And I'll say the route that we use is quite flat in terms of elevation gain over the distance. But Aubrey, we also adjust the settings on a lot of these cars, right? In terms of what you're able to use, not use. We talked climate, but even beyond that.
Yeah. So a lot of these EVs now, they'll have different drive modes. So if there is an eco drive mode, we'll use that. If there is an eco climate mode, we'll use that, as long as it's still able to maintain the 72 degrees that we want.
And we do that because after talking and surveying and doing user studies, frankly, on people who own these cars and really live with them, they tend to do that when they're trying to squeak out extra range, right? So we want this to be representative.
Yep. And one way that this differs from our gas mileage on all the gas cars that we do, we run those with no climate control on when we're testing miles per gallon. But on these EVs, the climate system is working because it is part of the battery conditioning system and cooling system and things like that. So the system's already on. Plus, when we're doing fuels, and I drive fuels a lot, on the highway, you're in the car for 45 minutes. This is hours and hours and hours. It would be a long, terrible day, if it was 90 degrees outside with a glass roof. So, and I wouldn't recommend anybody drive their EV with their climate off to get that last little bit either. I know we did a cold weather test without climate on, and that was terrible as well.
Yeah. Another thing is we use adaptive cruise control.
Yes.
We try to control our speed, not just with the car speedometer, but we confirm with GPS as well, because some cars, their speedometer may be off by a percentage point or two. So ACC with the closest following distance. And then drivers do have the option to use lane centering if they'd like. I know some people do, some people don't. It's kind of up to the driver at that point.
Right. Yeah, so all of this in the name, even down to making sure headlights are in auto if the car is a sunshade, keep it closed, right? Things like that. So really making sure that these, and I'd be remiss to not mention tire pressure checking.
We do alignments before.
Right.
Every car is charged overnight in a climate-controlled garage, and then we precondition the cars before we head out. If the vehicle can be preconditioned, if there's we can set a schedule. We do that. If not, as the tester, we know that ahead of time. You just turn the car on, you set your climate control, and you just let the car run while it's still plugged in to cool the cabin. Just kind of precondition the battery. That way, we're as close across the board as we can. It's car to car and test to test.
Sounds like a lot when we lay it all out like that. We're doing to prepare for each of these
when we're
tests,
doing
which
this,
is
we have
sweet.
that clipboard with all the parameters and all the things we're writing down, and it is quite a lot. But I think it's what needs to happen to do an accurate test.
For sure.
Yep.
So, Aubrey, why don't you start walking us through some of the trends? This is I think, third or fourth year that we've been doing this and refining things over time. But this past year in particular, some of the trends that we noticed.
Yeah. So, in general, what we find is some of the German brands like BMW and Mercedes tend to go significantly past their EPA rating. Other German brands like Audi are sometimes close to EPA or maybe slightly under. The majority of the Ultiums from GM, and that includes like the Acura ZDX, the Honda Prologue, Cadillac Lyriq, and all those tend to be fairly close to the EPA range. Tesla, again, very close to EPA in general. And then surprisingly, some of these, EV only startups like Rivian and Lucid, at least in our testing, they underperform. I know the R1S Dual Max that we tested this year, it's got an EPA range of 410, I believe. And our test result was 358?
Yep. Thereabouts.
Yeah.
Yeah. Kind of interesting. Using, the different cycles, right, could possibly be a reason that you might see some brands overperform, and obviously different specs on these vehicles, right, in terms of tires and things like that. But Yeah, Mike, any other big trends that we saw?
I think, I think Aubrey nailed those, but a couple of things to think about. Talking about the Ultium vehicles, we've tested those over a couple of years now. Basically, last year was the first time we saw, I think it was the Blazer and the Lyriq, and then we've had some of the other cars now. The earlier Ultiums, so the Lyriq, the Blazer, the ZDX, were all difficult to recover. And by that, I mean, when we run them till they stop moving and the car is essentially dead where it stands,
Right.
The way we recover all the cars is we have a couple of vehicles here. Some are EV. We used a hybrid F-150 for a while as well. But they have a 240 charging plug or a plug in the back of the vehicle in the bed. So we can plug essentially a home charger into it, put a little bit of charge in the vehicle, enough for it to power back up and move the vehicle off the track, so we can plug it into a wall charger where we then can measure how much electricity is being used to charge the vehicle back. And that goes into our efficiency calculations. But these early Ultiums, I would say most vehicles, 15 minutes plugged into the back of a Cybertruck or a Silverado EV, charging at about 3 kilowatts, give or take, is enough to just move it at a slow speed back to where we can plug it in. But these early Ultiums, they wouldn't even power. It was like they were totally dead. And even the first one, I mean, I went out there with a jump box thinking the 12-volt battery had died, and that wasn't the case. They take, in some cases, hours. You have to get them up to about 15, 16, 17% in a varied kind of car to car before you could put them in gear and actually let them move. So that was unexpected, and it was only sort of those early Ultiums that did it. When we tested the Silverado EV, it was about 15 minutes, and then that thing was able to move.
Right.
So, I mean, it's already a long day in that car because you've gone 400 and something miles.
Yep.
You're like, now it's going to be like hours to recover this thing. You're setting yourself up mentally for a long day, and then like 15 minutes in, it's like, I think I can move this car. And it was able to move it, and everything was fine.
Right.
So,
Did the Equinox EV have that too?
well, the Equinox EV, we had a different experience with.
Oh, that's right.
And
I drove that.
yeah, so I think this is where you tell that story.
Yeah. So when I drove the Equinox EV, I had done the range testing several times already, and we had done other Ultiums already. They had all behaved similarly.
Identically, basically. And I think one of the things is, as you get low in your SOC and range, especially for us running this test, because we know we're going to zero. We're trying to gauge where we're going to get off the highway. We basically have like a little cheat sheet of how far it is between exit to exit.
Yep.
And these Ultiums will change over at the end, and they just say low.
Yeah,
and you kind of lose
I had that happen
the
in the
last
Lyriq.
little bit of that sort of gauge that you have.
Yeah, I think at 15 miles of indicated range, it just disappears and says low. So where you thought you had 15 miles, now you think you have 15, but you're not sure because it just says low. And again, in the past, we found that you have at least 15.
You have
you can go
correct.
15 and probably still be safe. So in this case, with the Equinox EV, and this was a 2024 model, I believe they've updated a little bit since. So maybe the behavior's changed, maybe they addressed whatever issue I encountered, but right around 2% SOC, and again, don't know what the range was because it just said low. I just rapidly started losing power, and I was not able to maintain 70 miles an hour. So I basically had the accelerator pinned. I was losing speed. I was going up a very slight incline on 395 on the highway we test on, and I just had to pull over to the shoulder. And pedal pinned to the floor. I pull over and I just rolled to a stop.
I think you were the only one that this has happened to.
Yes,
so far.
correct.
Everybody else has successfully
I'm
made
honored.
it back to that.
So once it came to a stop, where it said 2% SOC, maybe 30 seconds earlier, it just said zero, zero range, zero everything, and I couldn't actually turn the car on. So the way these Ultiums, the way the high voltage battery switched, when you press the brake pedal, that's when the high voltage battery switches on. There's no power button. So every time I tried to press the brake pedal, the screens would flash and then go black.
Yep.
And getting this back to the track was kind of a nightmare.
Oh, it was terrible. So it was very hot out. It was like 85 something, like high 80s that day. Didn't have any water. I'm just stranded on a sunny portion of the highway.
This is why we try to avoid this situation.
Yeah, exactly.
Case in point.
And of course, the car doesn't have AC. It's completely dead. So I'm standing outside. I'm up on the embankment. Tow truck came in about 45 minutes, I think. And we can't get the car out of park, right? Because you can't turn it on, and this is an electronically shifted transmission.
Correct me if I'm wrong, you also couldn't pop the hatch to get out the tow eyelet. You had to like climb over the back, right? Because I think we were on the phone for that. You called me. It was like, how do I open up the hatch? This thing's basically dead.
No, I was able.
You were
to
okay.
do it. But in the end, the tow truck operator just ended up wrapping it around the wheels.
Yep.
So
I think we have a clip of this too that we were about to.
yeah. So we had to drag the car up the flatbed in park, and it's 4-wheel drive, so all 4 wheels are stationary.
Yep.
It's digging
Just
into the
skidding up
ground.
Yeah.
I mean, the winch on this truck was struggling. It's like 5,000 pounds, something like that. So eventually we get it on. We get it back to the track. I think, did we use the Silverado EV that time?
I hooked the Silverado
Pretty
EV
much
up,
pull it off
pulled it
the-
off
we
the
just
back of the
dragged it.
truck.
Yeah.
Yeah.
So it's I mean, that's one of the benefits of doing a test like this, right? Is not only are we seeing the actual result in terms of the number, but I mean, the situation you're describing is not something we were hoping necessarily
Yeah.
looking for, but the point is we get to see a lot of the behavior of these vehicles
Correct.
along the way. You know, most of the test is pretty unextraordinary during the 99%, but when you start to get low, it's what is the vehicle going to do to inform
Correct.
the driver that they're getting low. Some of my personal favorite implementations that I've seen over the years is, hey, you have X amount of miles of range left, go any further and you're going to be too far to get to the closest public charger, right? I think that's a nice
I think Tesla
integration.
does a good job with
Yeah,
that.
Tesla absolutely does
They
a good
basically
job.
say you're leaving
Forward as well.
sort of the range that you have to get to charger.
Exactly.
So, you know, are you
Others-
really sure you want to continue?
Yeah, exactly. Others do none of that, and
Yeah.
you're pretty much in a Aubrey situation where you just run out unexpectedly.
Yeah,
right?
correct.
Well, I got plenty of warnings, but previously those warnings, still allowed me to get off the highway.
Yeah, the Ultiums, we'd always been able to go to 0, and I drove the test of the Blazer, and it sort of dropped rapidly, sort of what you experienced. But I mean, I went a mile and a half like after 0 on the highway because that's just where the next exit was, and the Blazer was able to do it.
Yeah, sure.
So that your experience was a little bit different. I mean, it was still sort of overall the same. It's just that you got stranded on the highway.
Well,
basically.
right. I mean, at 2% SOC, I completely lost power,
Yeah,
and that
correct.
shouldn't happen until 0%.
Right. Yeah, I think just, in at the vehicle level, thinking about some of the results that we saw this past year, on one hand, we tested the longest range we'd ever seen, right, with the Silverado EV.
Yes.
Right, and one of the shortest, the Fiat 500. I think in general, we're seeing range increase, right? I mean, you see that if you just go look
Correct.
at EPA results, if you were to kind of project and see the trend over time, but we're definitely seeing that here. Any other trends that you guys are noticing or specific, vehicles that had a surprising result?
I mean, I think you sort of hit it there. Ranges are increasing, which makes us doing this test, more difficult.
Yeah.
If they were all the Fiat 500, it'd be kind of easy because you could be back by lunchtime. But range is sort of only half the story because you can fix range with a massive battery pack, like the Silverado EV. But it's at the expense of size of the vehicle, weight of the vehicle, efficiency.
Yeah.
And I think that's what's interesting about this test. We can actually look at efficiency numbers because in your average day-to-day, really the efficiency number is what matters, not your overall total range, because it kind of comes down to what does it cost me to drive X number of miles, daily, weekly, monthly, whatever it is. So,
And the more efficient the vehicle with a better charging rate, the more quickly you're going to add miles. If you're on a road trip and you're stopping to use a public charger.
Yeah, because if you have to charge a massive battery, even DC fast charging, it's going to take a while.
Sure. Yeah.
And having been the one to drive the Silverado, I would have absolutely welcomed an hour plus break to charge this if I would have had maybe a cool place to sit in a bathroom.
Yeah,
and,
you're one of
be able to get some water.
The testers here who just kind of goes for the long haul and no breaks.
I tried to. I have had to stop on a couple of occasions, but I sort of just want to get it done. And I kind of think if I stop for 10 minutes, I could be 10 minutes closer to being done.
Especially with a car like that.
And yeah, speaking of efficiency, I'm just looking at our chart here. Model 3 is our highest efficiency we've ever recorded at 4.3 miles per kilowatt hour.
Yeah, it's really high. Yeah.
I think,
And we're using the vehicle monitor for the efficiency itself.
Yes, right.
Yep.
We somewhat confirm it, right? Because we track how many kilowatt hours we put into the battery afterwards.
So I guess in explaining that, we have when we are finished and we bring the vehicles back, we plug them back in the same charger that we started with. So it's inside, it's a controlled temperature environment, and we can look at how much electricity was used to charge the vehicle back up, but not only electricity, but time that it took to charge. So we can look at charging rate, and then we can calculate an efficiency number based off of those numbers as well.
For the whole cycle too, not just, including losses with charging and things like that.
Yeah, because there are, charging losses. So our numbers don't always, to the 10th always match, because of charging losses and things like that. But,
and you'll see some cars, there's no necessarily standard on calculating that in the in-vehicle display, right? So you'll see some where they seem to be taking that into account, right? Those losses that we're talking about, and others not. So it's quite interesting. But you can find in the article on our site, there's a PDF you can download that gives you more of the details. And the efficiency is absolutely
and
one of those.
This is the first time we're actually providing this next level of detail, right?
We
we've
know
heard from
people want to see
readers
it.
that people want to see it.
Totally, and we're capturing it. So, and to that point, just to get a little in front of some of the criticisms that we've gotten over the years, right? We talked a little bit about how it's different than the EPA itself, right? Can almost hear some of the questions coming into our ears as we release this, right? But we do, when you look at the article or some of the information, we compare it to the EPA's published number, right? In terms of that combined number you walked us through, Aubrey.
Right.
And the reason we do that is because that's the number that most people are going to see when they're shopping for a car. That's what's on the window sticker. It's what's on front and center on EPA site, or even what the manufacturers tend to advertise, right? But we do recognize that it's not necessarily apples to apples. So you can go on the EPA's site, and if you click the right buttons, you can essentially configure the information to say, I'm only driving on the highway, and therefore what would my range be? Granted, still based on laboratory testing, so it's still different in that way. But we recognize that is a difference, and they don't make it available for all the cars, and you kind of have to know the cheat code to do it. But it is now there in the PDF. You can kind of see what our 70 mile per hour range test is in comparison, at least when available from the EPA. For
I think there's a few cars that just not available, but the majority of them do have it.
Yeah, and also another one is because different automakers, as we talked about, have a different strategy on how to handle the zero indicated miles, right? Some are like Tesla, Rivian, Lucid. We see them, zero is a lot closer to zero in a lot of cases than maybe some of these other cars. That's why you see some of these German brands going much, much further than their advertised range.
Correct.
That's why we take them on the track. That's why 100%. We drive them. We don't want to say zero is necessarily zero. So we're trying to exhaust the battery to really figure out and recognize the fact that they have different strategies there. And we talked about the temperature range with some feedback we get all the time. Like, that's kind of a wide range of temperatures, 70 to 90. Of course, try to keep it as tight as we possibly can, even within that. But we got to give ourselves some room for the next Silverado EVU
and
test.
We've done some testing even prior to this. We've done some warm weather testing, cold weather testing. We kind of have an idea. The 70 to 90, although while it's 20-degree range, that's sort of within the range of where these cars run. They run in the upper 90s in terms of battery temperature and motor temperature, like as you're running down the highway, with sort of a low load on them. So ambient being within that range, you're not really expending a lot of energy heating or cooling. We're just sort of floating there, if you will. And also,
so
I mean, unless you want to move us to like San Diego where it's just nice all the time, here in New England, it's cool in the morning and then it gets warm in the day. But then if the sun kind of dips below trees and stuff, like it can drop off pretty quickly too, especially like later in the year, like in September, or we'll get warm days maybe in October, where we can still kind of get some of these cars done.
Yeah, especially, starting early in the morning with some of these longer range EVs. I mean, it's still warming up. So
totally.
A lot of times we have to wait to start the test until it hits 70.
Right, exactly.
And then it, keeps going up. And we have used close to the full range in several tests.
Yeah, absolutely.
Yeah. But it's funny you bring that up about moving or different temperatures and such, because yes, we're somewhat ideal temperature range, where the cars are kind of happy. And then we don't retest in the winter, but what we can do is we know the general trend, right? We've done kind of, let's call them one-off experiments to say, okay, on average, you're going to lose, let's say 30% in this type of temperature, right? We can take what we test in the summer and kind of apply that learning and say, okay, in the winter, you'd see something roughly like this. All right, awesome. So you can go onto cr.org. You can look at the range test results. You can see the graph with all the comparisons to EPA, and then absolutely download that PDF and look at all the details that are in there and all the historical cars that we've tested too. So thank you guys for taking us through that. So we're going to move on to audience questions. And remember, you can send us text and video questions at talkingcars@icloud.com. And if we use your question on the show, we'll send you some swag, which is pretty cool. So we have today Gene from New Jersey, and he says, back in my day, yes, I know how that sounds, exterior lighting followed a fairly simple concept. Make it bright enough to see, clear enough to understand, and not so bright that it felt like a welding arc aimed at your retinas. But I find myself asking a few questions while squinting at oncoming traffic. When did turn signals become a design accent instead of a signal? Some are so small in daylight that I'm not sure if the vehicle is turning or just blinking Morse code. Why are we stacking multiple headlamp elements vertically on lifted trucks? I don't need to see the future, just the road. And what happened to good old-fashioned separation of brake lights and amber turn signals? Red for brake, amber for turn. It worked, it was clear, no guessing required. Technology has given us impressive capability. My only hope is that we continue applying it in ways that enhance safety rather than test everyone's night vision. All right, Gene, thank you for that. So we looked into this, and of course, sharing some of these observations ourselves, driving these cars, and just
I think everybody
being
does.
in the world, right?
Yeah, being blinded by every oncoming
So,
car.
Aubrey, why don't you start and tell us a little bit about kind of what we learned and some of what Gene is observing.
Yeah. So in the U.S., automotive lighting in general is covered under the Federal Motor Vehicle Safety Standard 108. It designates the size, color, and operation basically of headlights, taillights, turn signals, things like that. In the U.S., both red and amber rear turn signals are allowed, while in other countries, it's generally only amber. So it really just is up to the manufacturer. And some manufacturers that are selling more cars in Europe, they might choose to just keep the amber turn signals here because it's allowed. Sometimes it's more cost effective to integrate the brake lights, which are already red, into the turn signal. So they do that, and maybe those aren't quite as visible. There actually is some data that amber rear turn signals are safer for rear end collisions and lane change collisions, per some studies by the IIHS and NHTSA. So that's one part of it. And then I know, Cross, and you know a little bit more about maybe the headlight history.
Yeah. So I'll go back in the day with Gene here. For the longest time, there were basically two headlights. You had round and you had square, and they were sealed beam glass headlight.
Yeah,
and it didn't matter if you bought a Chevy, a Ford, or whatever. Everybody had the same Sylvania headlight in their car. And I'm going to say 1983. I forgot to put this in my notes here, but I think it was 1983. Part of this 108 document that if you ever have trouble sleeping, I suggest you bring this up on the government website and just start reading. There's a lot there. It's kind of interesting, but you'll be asleep. They wanted to start moving away from glass headlamps. And part of that was because they could now at this point. Plastics and injection molding and all this kind of stuff was becoming more readily available. It didn't happen in 83, but that's when it first started talking about, like, let's move away from these glass headlamps. So we got to a point where we could manufacture plastic, Lexan, whatever headlamps. And that opened up a whole new world of what they can do in terms of shape.
Sure.
So it was sort of the Aero headlamp time. And they were able to change the way the front of cars look.
Right.
Strictly, I think it was pedestrian safety, so you don't have glass out front, but also now the car's more aerodynamic, and this is, fuel economy is always a forefront in what manufacturers do, right?
Yeah.
A lot of things they do are for emissions and fuel economy, and this plays into that.
Right.
And then they got into the point where, like, hey, we can actually make these styling elements and make these cars really stand out from one another. So like the Ford and Chevy truck no longer have to have the same headlight in them, essentially. So, I mean, the downsides are it makes headlights more expensive because you have this custom one-off, headlight, essentially. You're not just going to the auto parts store and just buying the bulb, which is the assembly, kind of all that kind of stuff.
Right.
So it makes them more expensive, but they do work a lot better, and they certainly look in general a lot better. Although I kind of happen to like the older look of like just a round, glass headlamp on the front of a pickup truck. Maybe I'm just too nostalgic for that, but so they've definitely turned into a styling element in turn signals. But even looking back, way back in the day, Ford had the sequential turn signals in the rear of the Mustang. And there weren't really like electronics. It was like a little tumbler that had these contacts that would rotate.
Very mechanical.
It was, yes.
Of
course, new cars have that now too. It's all done with circuits and things like that. So they were always, I think, trying to incorporate lighting. It's a big element on the car. And like cars have, a lot of people say cars have a face. Like the eyes are the headlights are the eyes and the grill is the face and all that kind of stuff. And I think it works. And I'm going to call out Audi on this one.
Yeah, I think you would.
From like 04, I'm going to say, is when this showed up on the A8, but it's when they went to the LED daytime running lights. And I'm a firm believer that those cool looking, they look great. Those headlights are sort of what got Audi through the mid 2000s and why they still exist and why they ever sold any cars. Because they had the best looking headlights.
I remember seeing them for the first time and was like impressionable at the time. It just blown away by
BMW did the Angel Eyes. I think they might have been a little bit before that. but it's a big styling thing, and it really sort of makes a car look premium, and sort of upmarket, and like you got the good option car because you have the cool headlight kind of thing. So
yeah, and like you said about the face of a car, right? That's the first thing people see when a car is driving past them. So it just kind of became this arms race between manufacturers. Who can make the coolest looking headlights? And I mean, even today, you see like higher trim levels of the same model will have upgraded headlights. Like that's something that's premium that people are willing to pay money for. Is that like the better technology?
The Nissan Leaf, we'd borrowed one, that blue one, had the really cool 3D taillights and brake lights. Yeah. And then the one we bought
just
had like regular kind of lame
do that with the
taillights.
OLED taillights on the higher trims and whatnot. But yeah, it's and now of course with the LEDs, right, and everything you talked about, Mike, you could just your options are almost endless as long as you're within FM VSS, standards, right?
Correct.
But we're seeing some pretty crazy stuff. I mean, I've said it to both of you guys before, but like the Palisade really stands out to me. The new one, the front end, these giant lighting elements are also the turn signals, and it's got to be by surface area. I think I haven't measured this, but it's got to be one of the biggest turn signals we've ever
half
seen.
The front of the car glows.
It's actually kind of crazy. You see it almost looks like the old cornering light that you would get on some of these cars. Like at night when you turn it on, it just illuminates the whole side of your house.
And I think talking about headlights too, the vertical stack and the Rivian comes to mind because it's a vertical sort of light stack in the front. I think it would actually look better if it was maybe horizontal, but it's what they chose to do. But the headlights on that thing, the automatic high beams that's using, I don't know what they call it, but it's basically a matrix. And when you drive it at night, you can see them working. When there's a car coming at you, it blacks out certain areas to not blind and dazzle that driver.
Yeah. I think Tesla's got that too.
Yeah. And there's a lot where that is becoming more apparent. And because, like Gene said, this welding arc that you're looking at, and he's actually not wrong. We went from halogen lights to HIDs, which was actually essentially a welding arc. There was a jumping a gap with electricity in the actual burners, what they call it the bulb, but they call it a burner. So you were essentially looking at a welding arc when, in the late 90s, early 2000s, that's why they were so painful to look at.
Right.
Now they're basically all LED in most cases, but again, they're very bright. They have that really white color to them.
Yeah, they're intense, right?
Which causes a lot of dazzling. When we think about like old school fog lights were sort of amber in color or even yellow, that doesn't reflect quite as much as the bright, intense white. And that's another reason why it kind of hurts as well.
Yeah, for sure. So, and I think, the last thing just on this is while amazing styling elements and you can do all these crazy things, what it doesn't do is make the car cheaper or less expensive to repair or whatever. If you get an fender bender or anything like that, these lighting elements, I mean, some of these headlights can become thousands of dollars. Gone are the days of
all the sensors in the front bumper, right? Like you just bump into another car.
Right.
And there's modules in there and they require programming and they're VIN coded. And also you don't really realize how big they are. If you take a headlight assembly like out of the car, or if you're going to replace one, the box is like the size of this table. Of course, there's padding and stuff, but it's like, there's no way there's a headlight in there. But yeah, sure enough, that's what it is.
Yeah. So, we feel, Eugene, there's a lot of crazy lighting elements out there and it can be difficult at night, but as of now, this is the direction things are going. But anyway, thank you for the question. And as always, and just a reminder, please send us your questions, Talking Cloud.
Talking to clouds again, are you?
Gene's talking to clouds, right? Yelling at clouds. Send us your questions at talkingcars@icloud.com. That's going to do it for our show. Thank you guys for taking us through the EV range results. Check it out on cr.org, and we'll see you next time.